For the next several days, we're going to talk about how to graph y equals sine of x, and we're mostly going to be looking at how the equation and changes to the equation affect that graph and how we can sketch them by hand. So first, I just want to draw the basic y equals sine of x curve and talk about the different parts of it. Okay, sine of x goes up and then down and then back up. And that's what's called one period. A period is one complete cycle. So we're actually going to talk about that in just a minute, but a period is one complete cycle. Because after that it's just going to repeat. Because sine, I'm just going to draw it down below, does this over and over and over. So you can see you've got like from here to here's one period, from there to there, and so on. So you've just got the same shapes occurring over and over and over. So one period is one complete cycle. Now normal sine, again this is just regular y equals sine of x, has a period of 2 pi. So it takes 2 pi, that's the distance it takes to go one complete cycle. Now there's 5 key points or important points on the cycle. The first one's very simple, it's at 0, 0. Okay, the next 3, basically you need to split this curve up into 4 pieces. So you know it goes from 0 to 2 pi. So let's think about that for a second. If it goes from 0 to 2 pi, that means it's 2 pi long, and I want to divide it into 4 pieces. So that means each piece is going to be 1/2 of pi. Because this thing, 2 divided by 4 is 1/2, so it's half of pi. So I'm going to mark those spots. Pi over 2, 2 pi over 2 is just pi, 3 pi over 2, and then 2 pi. So these are the key points for sine of x. Sine has a range from -1 to +1. That means the lowest it goes is -1 and the highest it goes is +1. So pi over 2 is its maximum, and it happens at pi over 2, 1. Pi is one of its x-intercepts, so that's at pi 0. And then 3 pi over 2 is its minimum, so that's going to be at 3 pi over 2, -1. And then the last one is at 2 pi 0, because that's another one of its x-intercepts. So these 5 points, I'm going to highlight them with red, are called the 5 key points that we need to look at when we're looking at a cycle or a period of the sine curve. Okay, so we've talked about the period, that's one complete cycle. That can change, and we'll talk about how in just a minute. But for right now, I want to focus on a word called amplitude. Okay, for this particular sine curve, the amplitude is 1. Amplitude is simply the distance from the center of the curve to the top of the curve, or from the center of the curve to the bottom of the curve. Okay, so these are both the amplitude. So amplitude has to do with how high and how low you go. Another way to think about the amplitude is, if you start at 0 anyway, it's how high you go above 0, in this case 1, or how low you go below 0, -1. So a definition for amplitude would be the distance from the center of the curve to the top or bottom of the curve. Another way you can think about amplitude is it's half of the total distance between the top and the bottom of the curve. So if you think about it, sine goes up to +1 and down to -1. That's a total distance of 2. And so the amplitude is going to be half that number. But it's probably simpler to just think that's how high above 0 and below 0 it's going to go. And for today, that's going to work for us. So I want to explain how you can look at an equation of sine and figure out its amplitude. And that's really simple. If you have y equals a times sine of x, a is the amplitude. So if you look back, y equals sine of x. There's an understood 1 right there in front of the sine. We don't write 1 because it's just redundant. We know it's there. So 1 is our amplitude for that one. So let's check out a couple more examples, and we're going to sketch them and see if we can make sense of how they're drawn. Okay, give me just a moment. Okay, so here's an example to try. Find the amplitude of y equals 1/2 x and graph one cycle of it. So I'm going to give us a little more room to work here. So we know the amplitude is the number in front of sine of x. So our amplitude is 1/2. Now here's how I'd recommend you do this when you're asked to sketch these. You do not need to do these on graph paper. You can do them just like I'm doing here on the board on your paper. So you know sine shape should go something like this. Okay? You know that its period is 2 pi, and you know that each important point happens 1/4 of the way to that. So remember, you do 2 divided by 4, and that's 1/2. So we go up by 1/2 pi each time. Okay? Now, the only other thing you have to label when they ask you to do this is how high and low it goes. Well, like I circled in red, the amplitude of this is 1/2. So I'm just going to mark up here 1/2, and mark down here -1/2. And that's as much as you need to do. That's a good sketch for y equals 1/2 sine of x. That's as much as you have to do. Okay, let's try another one. This one asks us to find the amplitude of y equals 3 sine x and graph one cycle. So this time our amplitude is 3. So the number in front of sine x is going to serve as your amplitude. So I'm going to sketch this. Sine is shaped like this. I know it goes all the way to 2 pi. I know the important points happen 1/4 of that distance each time. And my amplitude is 3. So I need to mark that this goes as high as 3 and as low as -3. And that's all there is to it. Now there's one more thing I want to show you before we move on to talking about period and how it can change, and that is if there's a negative in front. Okay, so let's say for example we had y equals -3 sine x. The process is going to be mostly the same except for one thing. If you notice, the sine curves we've drawn so far all go up first and then down. So they go above the x-axis, then below the x-axis. If there's a negative out front, then that flips it around. So to draw this one, we would still start here at 0, 0. We would go down first and then up. So it just reverses the order. Instead of going up, then down, you go down, then up. Everything else is the same. You'd mark this as 2 pi, and this would be pi over 2, pi, and 3 pi over 2. And your amplitude is still 3, so it's -3 and +3 that you need to mark. So I guess I should point out, your amplitude is always the absolute value of that number. Your amplitude is not -3. That doesn't make sense. You're not going to go a -3 distance. Your amplitude is always the absolute value of that number. If you have a negative, then it flips it over like we see here. It goes down first, then up. Okay, so now we're going to switch gears and talk about the period. So let's draw a little more, write a little more general equation for sine, and that's this. Okay, A still stands for amplitude. And A and B are both constants. In other words, they represent numbers. We may not know what those numbers are, but they are just numbers. Okay, now it turns out that to find the period, you have to do 2 pi divided by B. Or just so you know, this may be helpful later, you can also say B is equal to 2 pi over the period. Both of those equations are actually equivalent, and you can use either one. So let me give you an example of one of those, and we'll look at that and sketch it. Find the amplitude and period of y equals 3 sine of 2x and graph one cycle. Alright, so we kept the same amplitude. The amplitude is still 3. Okay, but to find the period, we have to do 2 pi divided by b. Now b is just the number in front of the x. Some people try to bring the x with them. That's wrong. It's not the x, it's just the number in front of x. So I put 2 on the bottom for b. Just putting that right there. So then the 2's cancel, and I'm just left with pi. So in this case, my period is pi. So here's how this will change how I draw it. I still draw the same shape, but now, since my period is pi, that means instead of taking 2 pi to go one period, it just takes 1 pi. So I'm ending at pi. Now remember, I told you those key points, those important points, happen 1/4 of the distance of the period apart. So last time we did 2 pi divided by 4. This time we do pi divided by 4. So the key points, the important points, will happen at pi over 4, pi over 2, and 3 pi over 4. Because this time the period's different. So you got to make sure you divide that period by 4 and then label those points. Okay, and you know the amplitude is 3, so it goes up to 3 and down to -3. And that's all there is to it. Alright, let's try a couple more examples. Find the amplitude and period for y equals 2 sine of 1/2 pi x and graph the first cycle. Alright, amplitude is 2. Remember, the amplitude is just the number in front of the sine. Okay, now look very carefully. The number in front of x is 1/2 pi. So when I find the period, remember it's 2 pi over b. And my b is this right here, the 1/2 pi. So I put 1/2 pi on the bottom. So if you notice, the pi's cancel, and I just have 2 divided by 1/2, which is 4. So we get 2 divided by 1/2, which is 4. So my amplitude is 2, and my period is 4. So when I draw this, I draw the basic sine shape, and it ends at 4, because it takes 4 units to go one cycle. So then remember to label your key points, and they are 1/4 of that distance, so that would just be 1. So this would be at 1, 2, 3. And the amplitude is 2, so it goes as high as 2 and as low as -2. And that'll do it. Okay, one last example. Let's find the amplitude and the period for y equals -1/3 sine of, let's do 3x. Okay, so the amplitude is 1/3. Remember, you always do absolute value for amplitude. Amplitude is 1/3, and the period is 2 pi over 3. And that doesn't reduce, so you can just leave it just like that. But remember, it's 2 pi divided by the b out front. Okay, so when I sketch this one, I need to pay attention to several things. First of all, there's a negative out front. That means I need to draw my sine curve going down first. So it still starts at 0, but it goes down and then up. Okay, my period this time is 2 pi over 3. When I label my important points, remember they're 1/4 of that distance. So 2 pi over 3. If you need to, you can plug this in the calculator. 2 pi over 3 divided by 4 is going to give you 2 pi over 12, which is actually just pi over 6. Alright, if you're curious how I would do that in the calculator, let me pull that up. The key here is to remember that the fractions in front of the pi are just fractions. So I want to leave the pi, so I can plug in my calculator 2/3 divided by 4, and that gives me the fraction 1/6. So then I just put the pi with it. Pi over 6 is the same as 1/6 pi, or 1/6 times pi. So each interval is going to be pi over 6. So the first one would be pi over 6. The next one would be 2 pi over 6, which reduces to pi over 3. The next one would be 3 pi over 6, which reduces to pi over 2. So that would be the intervals that you need to label, or the key points, the important points. Now our amplitude is 1/3, so I would need to label 1/3 on top and negative 1/3 on the bottom. So make sure you're paying attention to three things for what we're looking at today: amplitude, period, and whether it's positive or negative. Positive goes up first, negative goes down first. Pretty easy to remember. Okay, if you want practice, then what I'd recommend you look at is page 505, number 1 through 16. That would be a good place to look if you need some practice. Page 505 in our books, number 1 through 16.